Hello, everyone. Welcome. Welcome. All right, so let's get started. So my name is Leon, and we're going to talk about performance a little bit. So obligatory slide about myself. I've been a developer for more years than I care to admit. Done a development actually in the public sector, worked for White House, Naval Research Lab, then did a lot of startups on the products. And for the past, I don't even know how many years, I've been working at OmniTI. And those who don't know, OmniTI is a true full stack consulting company, not like a hipster full stack where it's JavaScript and JavaScript. So we work across the whole stack, and we specialize in high performance and scalability systems. So that's either like startups who want to launch to the world and want to make sure they don't collapse after the prototype, or like big companies like Wikipedia, Facebook, National Geographic of the world who need a very narrow kind of fix the problem. So doing all that, I've seen a lot of really weird and really interesting performance problems that people hit. I guess unfortunately this talk is not about them. This talk is more about the basic performance, low-hanging fruits that I see in so many different code bases that will make any developer's life easier if they just knew about them or followed the rules. I guess what validates me a little bit that half of them Maud mentioned in her talk in Slack. So that kind of makes me feel good that I know what I'm talking about. So we're going to talk about different performance problems that you can hit as a developer specifically across the different types of stack and what you can do about it. Logistically, there's separated in kind of sections, and we're going against lunch, so we're going to have time. So if anybody wants to ask questions in the middle or after each section, feel free to. We don't have to wait till the very end. It shouldn't be a problem. Similarly, if you want to heckle me digitally, my Twitter is over there, feel free to. I don't get offended or upset, so feel free to speak your mind. So that said, let's get started. And before we begin, I want to give a couple of disclaimers just to frame this conversation. First of all, the performance is technology agnostic. And I know it's a PHP conference, but what I'm going to be talking about here applies to pretty much any language you're programming, whether it's Node, whether it's Ruby, specifically Ruby, whether it's PHP. And throughout the examples, I try to actually use different programming languages to use as examples, just to show that it's really diverse and it can appear anywhere. Performance is not scalability. I hope does everybody know the difference between performance and scalability by show of hands? Yes, maybe, kind of. The best example of difference between performance and scalability is when you have a McDonald's in the area and it can accommodate for all the traffic that's going through. Scalability is building 3 more McDonald's in the same area, and performance is putting automatic kiosks that will serve food much quicker. Right. One is you're trying to scale out to make sure you can accommodate more people with more types of resources. And another one, you're trying to streamline the process so you can accommodate more traffic through a single location. There's much more to performance than I'm going to talk about here. We only have like an hour, and I'm only going to touch base on the basic things. There is so much more about it that don't think that even if you're doing all the things that I'm discussing, that you're never going to have performance issues. It's constant, ongoing each process that you need to fix those. And lastly, it's almost all about the web. And the reason for that is because of the nature of web, right? When you're shipping your software on the CD, you don't really have this performance issues that you would if you have half of the world open your website. So a lot of the things I'm talking about here do apply to things outside the web, but primarily I'm going to talk about the web and loading the web pages and the traffic that comes from it. All right, so why performance, right? I mean, the main reason to improve the performance is because it improves the user experience, right? The faster the page load, the happier the user is. We all have a partial ADD, so going to the website and waiting for 5 seconds for it to load is just not acceptable. But also as a result, it affects business, right? The slower the page loads, the more users get aggregated, the more they'll leave. There's actual studies show that 100 milliseconds delay, only like difference between loading pages, is a 7% conversion rate. Which is not a lot, it's 7%, but if you're Amazon and you do like 70% of your revenue off of related products, like that's a lot of money. It also saves money in production, talking about a little bit about scalability and performance. So if you're serving like 50 users a second, which is moderate traffic, right? You're serving across 2 web servers at about 300 a month, right? You're paying 600 bucks a month, which is reasonable for decent traffic. But if that's the maximum you can serve on a single machine, just 50 requests a second, then if you get hit, if you get featured in a hacker's news, let's say, and you get 1,000 requests a second, all of a sudden you're paying 12 grand a month, right? And just like that, just because you're not at capacity of what you can serve through that one McDonald's, like I was saying. And that's actually why the cloud doesn't solve your problems. Because a lot of times recently I hear, oh, we don't have those problems. Like if we need something, we just provision new servers. I was like, well, how much you're paying for that AWS? And just to wrap up the whole scalability thing, this is going to be the only and the last slide on scalability. Everything else is going to be on performance. Don't scale instead of improve performance. Because the whole cloud approach, the whole I can bring out as many instances, is literally throwing money at the problem. And if you have a certain performance issues like a CPU hog, then you can scale pretty much indefinitely, and it's not going to help you. But also think about scaling when you're designing your application, because I've seen so many applications that were tested just on a single developer's box, and once they go into production, the design of it prevents it from scaling it out when you need to. So, all right, so on to performance. What can we optimize? What can we make more performance? What can make go faster? And the short answer is pretty much everything. Everything up and down the stack, we can make faster. So let's start on the top of the stack. Let's start with the front end. And as I'm going through it, I'm also going to mention resources that I find useful myself, so you can read or watch more stuff about this. So from a front end, there is a lot of talks. Actually, Christian gave a pretty good talk on the performance, and he also mentioned this book. How many people read this book? By Steven Souders? You should totally read this book. This is like the Bible for the front end. It is all outdated, and Christian went through it, but it still gives you all the basic things of how to optimize the front end code. It's all your, don't put the JavaScript and CSS on the front of the page. It's all your like gzip the files and the headers. It is a great book. Well, Steve Souders is probably the expert in the world. So there is a high-performance websites and even faster websites, which is a follow-up to this book. I highly recommend reading both of those. But I want to talk about one very particular thing that's probably the biggest killer of all the performance out there, and that's a single point of failure, right? And in the world of the web, it generally means a service integration, right? So everybody has something integrated on their page that goes outside. I mean, that's what's taken from archives, and it's a astonishing number. It's only 6.4% that has no third-party content on their website. 38% said between 75 and 99% is coming from somewhere else, which means you are relying on the data and on connection somewhere else in order to load your own site. So I wanted to see exactly what it looks like. So there's a nifty tool that lets you do this. It gives you all the dependencies. And this is what National Geographic magazine website looks like. All those things, and I know they're very small, it's hard to read, all of those things are external services that are used on the home page of National Geographic. But you know what? It's National Geographic, right? Let's take something near and dear to the heart. Let's look at the PHP World's website. It's significantly smaller, obviously. But still, it connects a whole bunch of things. It gets the fonts, it does analytics, it does the social stuff. So, but that's just very few of them, right? What is it? 6, 5, 7, whatever it comes out to. So what happens when they fail? Luckily, we can find out. There is a thing called webtest.org. I don't know how many of you ever use this. Anybody? It lets you do really cool stuff as far as single point of failure testing, as far as performance loading. So you can load with all those services disabled or tabbed out rather, and the regular website side by side. And let's see what the difference is. We can actually do it in real time. So it took about 3.8 seconds to load the main page. And if the services were to go down, like Google Fonts were to go down, for example, or I don't know, the social buttons would go down, or the analytics would go down, your user would still be sitting there waiting, staring at the blank page, waiting for something, just literally something to load. Oh wait, finally it's here. So, no matter how fast you make your code, no matter how much you follow all the procedures, If the third-party service fails, or what's worse, actually doesn't time out properly, which is a worse example, you're going to be sitting there and waiting for the page to come in without being able to show your own content. And third parties means no control. There is absolutely nothing you can do about it, right? You're not going to call Google and say, hey, like my site is not working because of you, right? It just doesn't work that way. So give you a good example, like I've seen that live. This is what happens when something fails. And again, what I showed you side by side is when you disable basically all the third-party connections. One failure is enough, right? So this particular example, somebody implemented Facebook Connect. Basically, they wanted to have a Facebook auth on their websites, and they implemented it incorrectly, like completely incorrect. So their initial load jumped about 4 times, which was fine. It was about 200 milliseconds initially, so it jumped to 800 milliseconds, which is painful, really, but not damaging, right? It was still acceptable. And then Facebook started having issues, right? That whole, oh my God, Facebook is down moment. And problem is that it didn't actually go down. It just didn't send any response to any request sent there. And the reason, going back, they implemented it improperly. They implemented the request to Facebook on every single page load. They didn't cache the response. Now, if you're already authenticated, they didn't cache it locally, they didn't store it in sessions. So every time somebody went to the site, they would have to go to the Facebook and get the credentials back or authorization that is done. So first, the site load times jumped about 500% because it was still waiting. To load any content from the site, it was waiting for the Facebook to send a response because it was a critical path. Obviously, when it didn't get it, nothing happened. And then Facebook crashed. And then the site crashed. And what do? Right? You have absolutely no control over it. So you have to frantically scramble and try to either remove it or try to put something temporary up. But effectively what it is your business depends on somebody else's competence. That's effectively what it is, right? And the beauty of this is it doesn't really have to be a third party. It can be your own. Like with the whole rise of microservices, service-oriented architectures, you do connect, you consume other services. And whether it's another group or just another part of your application, you can build it in a way that you're completely dependent on something that's not a main purpose of what you're trying to do. So in order to avoid this, you got to think about a couple of things. First of all, only connect to the services you need. You don't even imagine how many times you look at the code and you see like 4 different front-end analytics side in. And like, are you using 4 of them? Oh, no, those are legacy ones, but don't use those anymore. But you still connect to them, right? You still depend on them. So only connect to the ones that it seems straightforward, but like with anything, with any Strangler code, like you remove the service, but you never remove it from the code itself. So the dependency is still there. Avoid the external connections to critical path. That's pretty common sense, right? Your job, the job of any website, is to load the content for their users, or products, or whatever else it may be, right? There is no reason to put something in a critical path that shouldn't be there. Like ads is a perfect example. Ads generate revenue for most of the sites that go out there. But it shouldn't be on a critical path to provide the content they provide to the user, right? What it should be loaded asynchronously, right? Everybody knows the difference between synchronous and asynchronous loading, right? Yeah. Offload it, run it as a separate process outside of the critical path of what you're actually trying to do. Trap errors and timeouts. Timeouts is actually more deadly than errors in those situations. Because if something errors out, you get a faulty request. If you're doing it right, you just ignore it and move on with your process. If it takes a real long time to get a response back, your page is just sitting there and waiting. And have a fallback plan. And by fallback plan, I mean, if you trap that timeout and you see if you can't get the content you need, serve something else instead. So if you rely, let's say, I don't know, on Instagram or Flickr, right, to show your gallery, right, and it's not there, show some default images, right? If you're serving articles and you know you can pull them from some source, serve some stale content, because sometimes stale content is better than no content at all. And that's actually what I want to talk about front-end specifically. That's outside of that, read Steve Sour's book, watch the talk and whatnot. So any questions on this so far?
saw this with a client where they found out that their site didn't work in China. And that's because they were calling the Google API, trying to hit Google and block it all. And in 45 seconds, when the browser and the site went.
Yeah.
And to your other point, they weren't using that service anymore.
Yeah, and absolutely. And like I said, those are even worse than something is down. Because something is down, you get a 404, right? Or 500, whatever it comes out. And it comes out quickly, and then you have a different set of challenges what to do with this. But if it's actually a latency or something like waiting for a response but refusing to give it, then you're sitting there waiting for somebody else to do something. So, yeah, excellent point. All right, let's move on to probably the biggest bottleneck for performance that developers can deal with, and that's databases. And there's actually a lot of good books out there on database performance. Just out of curiosity, how many here use MySQL? Postgres? All right. SQL Server? Oh, there's always one in the crowd. Oracle? All right. Yeah, so there's a lot of good database optimization on. For MySQL specifically, because the majority of people use it, probably Baron Schwartz's book on MySQL performance is the best book out there. It's a fantastic book. For developers specifically, this is not a joke. Manga's Guide to Databases is probably the best book on SQL for developers. I mean, that sounds funny, but it is an excellent, excellent book. And I also like useindexlog.com. Marcus really knows his stuff, and he posts basically database independent performance tips on how to optimize it one way or another, so I highly recommend this. So there's a lot of different ways how a database can fail, right, specifically on the query side. But again, we're talking about developers, so let's not worry about database optimization. Let's talk about what developers can do. And the biggest problem I see everywhere, which is the most 101 issue, but appears in every single code base, is an N+1 problem. How many of you know what an N+1 problem is? I would have to venture to say that probably more of you have that problem than know what the problem is. So this is a classic N+1 problem. And this is a pretty standard piece of code, right? I got a blog. I want to get my own blog. So I get all the posts. And then I get all the comments for all the posts, right? Pretty standard. Replace blog posts with something else, right? Product and SKUs, article and whatever be. That's pretty straightforward. The problem with that is, well, before we talk about problem, let's extrapolate it into the actual code. And if you can't see it, don't worry about it. I'll highlight the important parts of it. So this is what the code would look like, approximately, right? So what we would do is we would select everything from post table, right, for me specifically. And then we would just select all the comments from a different table for every post because we have all those post IDs. The N+1 problem comes in from here. You iterate through every single post ID that you get back, which means if you have one post, you do 2 queries. If you have 100 posts, you do 101 queries. If you're an avid blogger and you have thousands of posts, your page will time out. And this is very common because, well, for different reasons. But that's not all. Like in that particular example, that's not even all of it. What else is happening is you're connecting to the database with every single query. And in a language just like PHP that is awful with connection pooling, which means you're going back and forth to the database every time you're making a query. So, and it's not that much of an overhead, really, right? It's a small thing if you just connect and disconnect. But if you do it enough times, it actually adds up, right? Especially if you have hundreds of thousands of requests back. And when it adds up, like, you only want to connect and disconnect twice. So the right way you want to do it is, actually, you want to do this. You want to run one query. You never want to run a query in a loop. When I say never, put a little asterisk next to it because we'll talk about it later. But you don't want to run a query in a loop, right? SQL has great things called joins. Like, join the table, get the results back, and then work them in the database. Because in that particular case, you have one query no matter what you do. Also, as a side note, a little tip, specify the columns you're selecting back. Because it does add to the performance. When you select everything from every table, it becomes a really wide return set. And it actually plummets the performance. So if you actually join your content and you don't loop over your queries, you have one query, one post, 10 queries, one post, or vice versa, 100 posts, right? You always run one query. It's just a result set that you get back differs. Specifically around reducing queries and making them faster, common table expressions. Anybody heard of them? Awesome. MySQL now has them too, finally. Before it was Postgres, SQL Server, Oracle. What it is actually an ability to work on a return set or return values from one query into another. So like generally you have what? 10 queries per page, roughly, right? You get your user information, right profile, maybe get your content, whatever it be. You can actually run most of those queries like in one single query and operate with the data in there. It's really, really cool stuff. My colleague actually wrote an article on this, so I highly recommend reading it and generally read some stuff about it. It is nice. So that said, after we do all that magic stuff, now we have one function saying get all posts with comments, right? And it gives us everything we need. So basically, instead of writing all that stuff all over the place, we have a function that it just returns what we need. It's nice and performant, and that's awesome, right? Because we have one function and we don't have to worry. Except for going back to the original example. We don't know what's under the hood, right? Like we had that function, get with comments. It could have been N+1 problem. Which brings me to probably the most controversial topic of today's conversation, which is ORMs. Before you start throwing Rotten Tomatoes at me, I'm not saying ORMs are bad. I'm just saying they're evil. And the reason for that is because you have no idea how they work. And I know some of you are sitting there saying, oh, I totally know how ORM works. No, you don't. People who write ORMs don't know how ORMs work. And the reason for that is, first of all, it's machine generated, right? What you get out of it is, yes, there's some logic that was put by humans, but because the variety of the conditions you can send in to get something back, you don't actually know how it arrived to the optimal results. Object construction overhead that nobody thinks about, we're going to talk about it, is ridiculous, and it gives you a full sense of control, right? You think you have this great thing that will do this magic stuff and return it for you, you don't have to worry about it, which realistically you do, right? ORMs, think about ORM is the most junior developer you ever worked with, right? And he's sitting there, he's trying, and it's fantastic, and you can give them basic queries, they can write basic forms, basic pages, but when you need something more complicated, like I actually had to reduce the font to minimal possible, because this query runs in milliseconds. It does a behavior targeted on ads for individual users, and it runs in production for hundreds of millions of people. Can your ORM do this? Right? And again, that is excessive, right? Because clearly nobody will try to do it with the ORM. But think about it perspective, like database and the schemas become more and more complex, so being able to deterministically pre-program all the conditions and variations in the most optimal way is, I don't want to say impossible, but let's go with that. But this SQL itself is not even the biggest problem that you face with ORMs, right? The biggest problem that you face with ORMs is the fact that object construction overhead is ridiculously expensive. Like, nobody thinks about it. When people think about ORMs, they think about SQL, whether it's optimal or not optimal, whatever it be. Nobody thinks about the object overhead. The whole reason it's object relational model, right? It's supposed to return you the objects from the data that you have. I'll give you some numbers just for visual reference. So on ORM that shall remain nameless, there was a query that was returning in 6.33 seconds. So in order to get a data set that it needed from a database, it took 6 seconds to just get that. So that's less than optimal, to say the least. So I was talking to a developer, I was like, look, you're using ORM breakout, just run the basic SQL. And they ran the SQL just to see whether they could optimize the query, and they ran exactly the same query in 0.6 seconds, which is still not great, but it's 0.6 seconds, right? It's not, I'm like, well, okay, cool. So there's something issued, there may be some indexes that ORM is missing. Put in the raw SQL in your thing. So instead of just using raw SQL and raw object, he put in raw SQL and you still had to build the objects, right? So instead of ORM building SQL, just build the SQL by hand. And that was the result. basically indeterminable. So the 6 seconds, well, 5.7 seconds out of 6.3 was actually constructing the objects, right? It was getting data quicker. It was getting data in about half a second. And the rest of the time was about building the objects and building all this relationship and typecasting and whatnot. And what's worse is those get all calls, right? Because A, it's the number of data, you're not getting just one object or one nested object, you're getting a whole set of nested objects. And B, you generally don't know what are the objects that you're getting. So anybody does Ruby on Rails here? No? Good. So Ruby is, Rails specifically, Ruby is a decent language. Rails was built for ease of use for people who don't really know how to program. That's my definition of it. And it creates a really nice ORM abstraction layer that you can actually get all the information database that you need. So just to get all the articles, well, this is one topic, like you just do articles all, right? You tie it to a table, where we set the relationships, and this is all you have to do. Problem with that is that when you define the articles, there's many more objects associated to this. So an article can have multiple authors, right? And each author is an object. So there's that. It can have many images, because you can have image galleries, you can have images spread up across the article, you can have quotes that you use, you can have comments, right? So once you do that, now you have, let's say, hundreds of articles in a system. And each of them has dozens of sub-objects. So all of a sudden, in order to get all articles, just to display, in a list in a search, let's say, you have to build dozens of hundreds of objects in order to return it back. Not the best thing. And honestly, ORMs has gotten a little better at it, especially with large data sets. You can do things like lazy loading. You can do all sorts of stuff. Lazy loading doesn't solve your problems. It solves some of the problems. It allows you to construct your application better. But it does run in the opposite side of the issue, where you have to run multiple queries now, which is also suboptimal. So you have to balance how you do this in actual time. So to sum it up, ORMs are bad for high traffic production. If you run something in production, like I said, and you have to construct all these objects and run suboptimal queries, you probably don't want to do that. It's also bad for replacing SQL skills. So many times I hear it's like, oh, ORMs are so much better because I don't have to learn SQL. And this is a really flawed mentality in a lot of ways. First of all, I find SQL simpler than most of the ORMs. Right? And second of all, SQL is pretty much universal, since Oracle, clearly. But it's universal, right? When you're switching jobs and you're going from one ORM to another, you need to learn a completely different system. So, yeah, so don't try to replace SQL knowledge. You need to know SQL. However, ORMs are good for prototyping because you don't have to deal with queries. You just build it out, see how it works, and then you can optimize it. Low traffic systems, honestly, you're serving, 20 requests, 50 requests a second, and you're getting decent performance with the ORM. You don't need to switch it out. Right? We're talking about something that actually impedes the performance gain. In non-public systems, right, there is no reason to say that you can run ORM and non-ORM, like query constructions, in the same system. Right? I have a lot of systems that have admins and all the backend stuff, back office channel, running ORMs because honestly, I've wrote so many CRUD objects in my life that I don't want to do that anymore. Right? So if you need to create a new page to just store something, I'm not going to use to write a SQL by hand. I'm going to use ORM. However, in production, when you don't just get individual objects or set of objects, you do complex relationships and logic on them, you want to probably break out and optimize for performance. All right, this concludes the database part of our conversation. Questions? Immediate questions, concerns, arguments that ORMs are awesome and I'm wrong? Go ahead.
One reason that I use ORMs is because so that I don't have to rewrite SQL queries again and again. So when you're using raw SQL, how do you manage that so that how do you reuse your SQL snippets?
I have to repeat the question in the microphone. But the question was how to reuse the SQL snippets when you don't use ORM. Exactly the same way. You build your object, right? You have you can even put it in your ORM object structure itself, right? You have a function saying return production dataset, right? Which is my query. And whenever I need to return a dataset, you call that function instead of ORM specific one. So you can still build it on top of the whole ARM model where you have the object structure, but you just have functions for the raw SQL instead of ORM generated ones. Right, same way, you don't write them individual ones on each page, right? You still put them in modules, and you still call by functions. Yeah, the way you do it, again, depends how much you want to separate the two or embed the two. I have systems where most of the things run in ORMs, except for certain queries, right? So certain questions are explicitly overwritten to optimize the queries. I have others where ORM is there, but you basically add the functions or override the functions you need to run it. And I have the ones that separate completely where production doesn't even load the ORM objects. Because some ORMs actually do some preloading stuff before that, and you don't even want to have that in production. Yeah. No more questions? All right, moving on. So, at some point you can get into a problem that you can optimize, right? How many of you have access to actually hardware and servers that you can make changes to them or directly on the databases? A lot of them? A few. So what happens when you can't optimize, right? What happens if you figure out there's a performance problem which you can't get to the database, right? You can't optimize the query like that. Or what happens even more often when you're in the middle of a Black Friday and everything goes wrong and you actually don't have time to rewrite the code because all the customers can't get to the site to buy something on the biggest day. Not like I'm speaking from personal experience. So if you can't optimize the problem, you hide the problem, right? And that's why we're going to talk about caching. Caching is effectively the way to hide the problem, right? Because you're offloading the problem somewhere else. There are only two problems in the computer science, right? It's caching validation and naming tags. And caching validation is an interesting problem, but you can avoid it in a lot of ways. But specifically with caching validation, a lot of people are worried about doing caching on caching specifically on the developer side because of that. It's like, well, what if I have a stale content, right? What if I don't invalidate cache fast enough or timely enough? But at some point, you got to ask yourself, is stale content better than slow content or not, right? And it truly depends on what you do. If you're a high-frequency banking, stale content does not work for you, right? Because even in milliseconds of delay in that, we can crash stock market, right? If you're serving articles, how often do you change it, right? How much do you care that the article will appear now and not in 5 minutes, right? There's probably a certain degree of care, but you'll be okay if that happens, right? And keep in mind that stale, whatever content or whatever asset is all relative, right? Like I said, high-frequency banking stale is milliseconds, right? So you have to consider it, and you have to consider how valuable is every minute, every 5 minutes, every half an hour to what you're doing. Like, a lot of times I talk to people, and they're like, oh, we can't cache anything. We need the real-time content. I was like, do you really? Like, I feel like your definition of real-time is different from mine. So that's a question, right? But you don't have to cache for 30 minutes, because I heard some people saying, oh, we cache it for like a minimal period of time, 30 minutes. Like 30 minutes is not the smallest increment you can cache for, right? So 1 minute, how valuable is 1 minute if you cache for 1 minute, let's say? So let's look at the example. If you do 100 requests a second, which is decent traffic, across 2 web servers, right? So, and you cache for 1 minute, which is 60 seconds. You serve 2 requests that hit your servers, which means they go through the process, they build your objects, they do a display, and you do 11,998 requests that hit the cache. Right? How many of your businesses cannot sustain a 1 minute latency in new content? How many of you can benefit from offloading 11,998 requests a minute? Right. And again, that's just 1 minute. More often than not, like 5 minutes is pretty reasonable amount for anything you do, unless it's really high frequency or high sensitive, time sensitivity stuff. So defining that is pretty important. And beauty of the thing is you can cache stuff on so many different levels, even as a developer. There are so many things available that you can use. So first of all, we'll talk about browser caching, right? Browser caching is interesting because it's completely remote. But you want the browsers, when somebody comes to the website, you want them to not go to your server, right, within a certain period of time. So if somebody's hammering your page, you want to first load to get the information, and then like hammer away, you're hitting your own local cache. And the way to do it is with cache control headers. How many of you use cache control headers? That's awesome. That is not awesome. That is not all of you. Cache control headers is basically a way for like front-end proxies and browsers to cache their requests on their site. And they're really easy to set up. Like if you use an Apache, in your Apache access, you just set cache control header and max age. So in this example, you can cache every single page or every single asset that's being served from your site for a month, right? So anybody who was, so if I go in and I load your page, for the next month, I'm going to see the content from my cache. Unless I go clear the cache, of course. The problem with that is you probably don't want to cache everything from 1 month because content does depend on what it is. But you can cache all the static assets because theoretically, you should never update images just because how internet works. Because somewhere, somehow, there is a copy of your asset that you've had, that is stored, that is cached, that you can't get rid of. So how many of you actually overwrite your images under the same name? Good. Good. Don't. It's really, really bad practice to overwrite assets. But you can cache them for at least a month or a year because like if you follow that process, cache them forever, and this way, you're actually offloading caching somewhere else. You don't even need the infrastructure to cache. Like browsers do it for you. You can also set it in individual pages. I don't really recommend it because it's very hard then to figure out where you've been cached. But you can implement the framework where you can define individual pages, how long they're going to be cached and whatnot. Things like that happen again when you troubleshoot in the middle of the night and you need to get something out quicker. But you can define it per page, and then you can do a really creative math. So when you're actually seeing the traffic coming in, you can up or down the cache times for particular pages and kind of balance your load that way. Biggest issue, of course, is you don't control browsers or those front-end caches, right? So if somebody uses incognito windows, they'll never hit the cache because incognito windows don't store caches. Same thing if somebody clears the cache, or what's worse, somebody doesn't clear the cache, right? There's really cool things you can do with the front-end caches too with service workers. Any of you heard of service workers? Use them in production? I'm with you. It's kind of a new thing that people are just starting to use. If you're interested to listen to Patrick's talk on service workers, he's actually the guy who works on PageSpeed tools, works for Google. Really cool stuff, but basically what you can do, you can define a browser-side rule set and logic, what to do with your content. So you can set up like an edge CDNs, you can do like variable caches. It's really cool stuff that you can do. All right, the second the way you can cache it is in-memory caches. That's probably the most traditional way how caches are implemented from a development perspective. Memcache, Redis users out there, yeah, probably most of you or a lot of you use it in one place or another. Beauty about it, they can be used either locally or distributed, right? I mean, ideal scenario, you have your own Memcache or Redis cluster out there that you connect to, and it's remote or stores everything. You can also have an individual node running on each one of your web servers, right? If you don't really care. And this way, you're getting a hit to each web server, but every time a web server is hit, you cache the content and serve from local content. Obviously, the issue with that is that it's in memory, so if you reboot the server, your cache is gone, so you have to repopulate it. And it's really easy to implement for those who never implemented it. Basically, this is what it is. That's all the infrastructure that you have to inject and you have to put around. Basically, you connect to Memcache. You create a Memcache article. Basically, you try to get the article out of it with a unique ID. If it's not cached, you get the content and you cache it, right? And next time it's going to be cached, you're going to return cache value. I mean, it's really straightforward. If you're not using it, I recommend to. I mean, basically get all the data from a database, dump it in Memcache, and next time you don't have to hit database. Again, available from developers and whatnot. For those situations, actually, when you don't have an option of using Memcache or Redis, because we live in DC, and there's a lot of government and healthcare around with all sorts of bureaucracy regulations where developers can use the tools they need. So if you can use Memcache, you can actually implement your own on this cache. It's not ideal, but it actually do the job. And it is exactly what you think it is, right? It's the same process. If it has cache, store it. If it has, check if it has cache. If it does, read from cache. If not, right, to the cache, right? And it would look something like this, right? You basically open the file, you check, you write something to the file, and the other way around, you read from the file, right? The only issue with that is, this is pretty straightforward, right? This is open file handle, open file handle. The only issue with that, you have to manage your own details, right? So you have to manage your own time to life. Whereas Memcache sets it for you. You basically say, hey, I want to cache it for 5 minutes, for a year, or whatever it be, and it actually manages for you. So every time you try to pull it out of cache, it'll automatically do the check. So if it's past the time, it'll say you don't have anything in cache, store something. Here you have to manage yourself. But it's also not difficult, right? You have the cache, you basically check the timestamp, right, on the file, last updated. If it's within the time frame, drawbacks of that, of course, is it's a file system bound, right? You have to create a cache on each individual web server. You still write into a disk, which, again, it's not ideal for performance perspectives. But it doesn't go away. It's persistent. So even if you're with the server, you still have your caches. So not the ideal thing, but can be done. So generally, if you have something like this, which is pretty much every single function that we use, all you have to do is put some caches around it, and that's pretty damn trivial. And however you implement it, you can actually abstract it completely out and switch between the caches, right? You can either switch between the caches or implement different layers. There's a lot of cool stuff you can do with it. So as a good example of why caching is important, remember the whole articles get all, right, that we talked about with Rails? So this is what get all looked like on an API call. It took 5.7 seconds to return. And I was still curious because I was like, query is okay, yes, there's construction overhead. There's also a ton of data that it returns back, right, because you got to send it over the wire. What's worse is when you put it under actual traffic spike, it more than doubled on the return time. I mean, it was unacceptable to begin with, so double and it is, yeah, but it's basically unusable. If you're using the cache, right, the base code takes under a second. And what's beautiful about it, it doesn't go up when you have traffic. Because you're pulling that from memory, you never hit the disk, you never pull it from the database, you never have to do it. And you never have to do the construction again, right? You already have done it once, you cached it, and you pull it out of it. One thing that a lot of people don't think about is caching is not just for database results, right? Everybody's using Memcache to store those data, those objects. You can cache pretty much anything. Like, you can cache HTML pages completely. Who here caches HTML? A couple of people. Yeah, you can cache HTML. Right, why not? Like, you build the page, you went through the effort to run all the queries, you constructed it, cache it. This way you don't have to do the job again. And it doesn't have to be 100% static. You can actually do really creative stuff with partial dynamic pages, because that's the biggest concern, right? We have personalization, we can't cache anything. Well, you can't cache personalization, you can cache everything else. So those are two different things. Theo's book on scale monitor architectures. It's a little outdated now, but chapter 5 actually talks about a couple of ways of doing a multi-level cache with static and dynamic content. It just gives you an idea, but there's a lot of cool examples that you can do in order to set it up. So you can cache pretty much everything but the dynamic portions you need and still live on this. Don't forget to purge. Remember we were talking about that hardest problem is cache and validation? Don't forget to purge the cache, especially if you're being creative with your TTLs and how you're caching stuff. Don't forget to purge the cache. And there's two ways of doing it, actually, other than like Memcache automatically doing it for you. You can do it on demand, and you can do it on change, right? On demand means similar with a file system cache, right? Somebody hits it, you check the cache, right? If it's invalid at times, you change the cache, you put in the new content. On change is if somebody goes into their content management system and updates the article, right? You don't have to wait to go to the cache until it actually hit. You know exactly what changed, you know the dependencies, so you can go and validate all the caches that you need for that particular content piece. So you can do that. And be careful on what you cache. So if you cache pretty URLs, for example, I had a situation where we built a really large system for people, and then we handed it over to their internal IT. And at some point, I was at their offices talking to somebody else, and a guy catches me in the hallway, goes, you know what, after we took over, there was a problem. Like, can I pick your brain at some point? I was like, sure, why not? What's the problem? What's up? I was like, well, We have this whole user submission of assets, right? The whole like Flickr style thing where you can submit your images, you can submit it to contests and whatnot. It's like, yeah, okay. It's like, yeah, and it's broken. I was like, okay, why is it broken? Like, well, no matter who you log in as, it shows you some random pictures. Like, I wonder if you're going to have some time to look through the code and see what's broken. I was like, I don't need to look through the code. Like, did you put a caching layer in front of it? Like, well, yeah. Like, did you cache based on the URL? Like, well, yeah. I was like, so you cached my profile without any regard for session. My profile for me is different than my profile for you, right? Or for you. But if you cache the first hit, the first person who goes to their website will cache that page. So now everybody who goes to my profile, no matter what the session is or authentication is, will see my pictures. And actually, it goes the other way around. It also works the same way for ugly URLs. So speaking of ugly URLs, speaking of sessions, somebody implemented sessions as a query string parameters. So every single page has a session as a query string parameter. And to optimize for performance, somebody decided to implement the file system cache, like we talked about, store it on disk. Except they stored the full URL, which means that if I go to the site and I go through 10 pages, it would store 10 pages, right, in the cache, naturally. However, if you go to the site and you go to the same 10 pages, it will store another 10 copies because those are different URLs, those are different session IDs. It took less than 10 hours to run out of this space. And considering it was an e-commerce site where you have products and related products, yeah. So make sure that you know what you're caching. And there's other types of caching, right? There's external caches that chances are a lot of developers don't have access to, but can still do something with. We talked about reverse proxies that are spec like cache control headers. Anybody use Apache Traffic Server, Nginx, Varnish? Those are great to front load the traffic on the cache stuff there. How much access you have to them is questionable, so still good to know how they work. There's, of course, CDNs, which are just the variations of those proxies. Like, I know Fastly runs on a modified version of Varnish, for example. So know them, use them for whatever you need. And CDNs, one note I wanted to make, is not just for static assets. You can also cache pages with most of the major CDNs. So use them, and you can set up all sorts of cool rule controls, right? You can say, patch this page for this long, give this period of time, or this coming from this angle. And you can use as few or as many of these techniques, right? You don't have to go in and it's like, oh, this is awesome, I need to cache everything, I'm going to implement all 5 things. Like, you might not need to. Just do them incrementally, use one, use two. Keep in mind that the more caching layers you have, the more cache and validation you have to sync up. Not only do, but sync up. So there's so many situations I've seen where people started panicking because there is stale content or incorrect content, which is worse. And you're looking, I was like, it's cached somewhere because I clearly can see it, but you have so many layers of caching that you actually have to go through each one and see if you can invalidate it and see where it's wrong. So there's that for caching. Questions, comments? Too much information? All right, so one last thing I want to talk about, I think we have a few more minutes, is queuing. And queuing is an interesting thing that a lot of people don't think about when they try to optimize their code. And remember the whole thing we talked about, the critical path, and don't put anything in a critical path? Well, we're going to take it a little bit to an extreme here. So think about this perspective. Anything not pertinent to the immediate outcome should not be in a critical path. And you really need to think about what is important, right? What is the goal you're trying to, end goal that you're trying to accomplish? So a really basic thing, right? A user registration, right? A user registers into something. We create a user object, we store it, we store the preferences, we send a welcome email, and then we display them a welcome page, right? With probably some upsells, whatever be. So what would be the ultimate outcome? What would be the main thing that we're trying to accomplish here from a user perspective? Anybody? welcome page, right? We're trying to show user a welcome page as soon as possible, right? Yes, internally we need to store the information, right? We need to send the email, we need to store everything. But from a user perspective, they click and register, and they want to see that welcome page, right? So everything outside of that, we have to evaluate whether it's actually needed to be done before we show that page, right? And looking at that, what's the outlier here? Sending the welcome page, right? Right, do we need to send an email before the user sees the welcome page? And chances are the answer is no, right? Because email can go in minutes, in 5 minutes, right, 10 minutes. On top of that, you don't know, again, going back what's under the hood. Send welcome email can be more than just send an email, right? Because you need to build the content. And honestly, a lot of emails are pretty complicated. So maybe you want to give like a deal of the day, right, to upsell somebody right now. Maybe you want to give them the offers that are relevant to them based on their information. All of that takes resources, takes time to build out and send, right? Do you really need to do it before you show a welcome page to the user? And the answer is no, right? So what you want to do is you want to queue it. You want to queue it for later. And my definition of queuing is putting things somewhere else to deal with it later, really, right? Because you still need to do it, but you don't have to do it immediately. So can you send your welcome email in 5 minutes? Yes. I mean, I honestly, I can't think of an example when the answer would be no in this particular example. You can send a welcome email. Chances are you can send it within an hour or the next day or within 12 hours, whatever the business rules are. So you can put them in queue somewhere and process it later as a side job that doesn't directly affect the user experience. And you can queue it in all sorts of different places, right? You can queue it in memory, RabbitMQ, SQS, people use it, maybe. One person, that's weird. But you can queue, there are queue solutions out there that let you just store stuff in queue and listen to things. You can actually queue it in a database. Like traditional, you would just store it in a database queue and they have a job process it, seeing if anything new came in and delete it. Postgres has really cool stuff, for example, that like listen notify, which you can implement proper queues and listen in on new data coming into a particular table. If you use a Postgres, I recommend looking into it because it's a really good way without having to add another piece to your architecture. You can use the same database you use. And really, you can queue any action, right? So you don't have to have, like, oh, I have this queue for emails. I can use it for anything else. You can queue any sort of action. As long as you can distinguish what the actions are, queue all sorts of stuff, right? Queue whatever you don't have to do in the main thing. And process when convenient. And convenient may be, again, in 5 minutes. It can be almost immediately, but outside of the main process, right? Asynchronously. It can be within the 24 hours. Like all sorts of logic you can put around it. So do that. Take it out of the critical path. Questions about queuing specifically? All right. So we optimize everything, right? I mean, that's what we're talking about. And yes, but I'm sure you've seen this quote even in the past couple of days. Premature optimization is the root of all evil because you can invest a lot of time and money into trying to optimize for something that you really don't need to. So when you're doing it, like specifically when you think about improvements of performance, think about they should be needed, right? You need to optimize for something. Like I said, if you run an ORM in production and your user experience is acceptable, then why invest time in optimizing it further, right? And it's incremental. The thing with performance things, you cannot predict the value of the change that you make. You make the change and you have to measure it, right? Measurement is another big part of what you need to do because you need to see what was the impact of the change you made. Because a lot of the performance problems are either hierarchical or dependent on one another. So by eliminating one, you can devalue or uptick the other problem easily. With that said, performance is not a feature. You cannot create a Jira ticket and say, I need to improve performance. You cannot just think as like, hey, I'm going to build my stuff and then I'm just going to optimize it for performance. You need to always think about the performance, right? All those examples, like, it is not that easy to find them in code, right? Especially when you build your full code, launch it, and they have performance problems. You're going to invest much more time trying to troubleshoot it and trying to come and figure out which functions and trying to profile it than if you think it up front. And one parting tip, there is exception to every single rule of what you said. I know we as developers, as technologists, we tend to think in absolutes. So Like when I say ORM, don't use ORM in production, I'm sure there are people right here saying it's like, oh my God, he doesn't know what he's talking about. I totally use ORM, so it's great. And it's fantastic. Like, if you don't need to use cache, don't use cache, right? There is exception to every rule. Make sure you assess what you're trying to do with what you actually need to do. So logistically, you can always reach me. You can email me. You can Twitter me. I actually already have slides and slide shares if you want to go look at it, and I'll also tweet it out. Join in, go, comment, leave your feedback, not just for me, but for all the speakers that you heard. It's actually very valuable. And if you want to know more, actually after having this conversation specifically about the performance, I started like a Medium series on performance tips. Some of the stuff that we talked about, pretty much all of the stuff that I talked about here will be there at some point whenever I get to write it. So yeah, feedback is definitely welcome. Also contributions. I'm not the only one who deals with weird performance problems. So if you have something interesting that you like to share, I'm definitely happy to add it. I want to create a resource where I can point people, say, hey, read through that and it may help you. Because I do use the code examples and I use the real examples that are running in production. And with that said, thanks. That's it for me. Any last minute questions, comments?
How come no one ever mentions Redis? Whenever you talk about doing it, Redis doing is fantastic. You probably already have it installed. And it works. I mean, maybe there's some higher end, higher level features don't exist, but is there something I'm missing here? Is like Redis doing not fantastic, or?
It's just, question was, why does nobody using Redis queues? There is no reason. I've seen people use it easily. I mean, I've used React while it was still a thing as a queuing method as well, right? You put a round robin and just queue it there until you push it to a persistent database. If it works for you, use it. There is nothing wrong with it. Like Rabbit is probably the most popular one and the most known one. SQS, obviously, because it's part of Amazon platform, so a lot of people use it. But Redis is not as bad at all. Again, you have to have it installed, right? And chances are explaining having it installed and running, especially if you have to go through ops people, is yeah. Any other questions?
How do you determine whether the use of file affects performance?
Profiling would be the short answer. Question is how do you determine whether using include files affects performance? But I also maybe go into the whole premature optimization. Yeah, profiling. If you have a few minutes, I can actually show a real example of what profiling showed and how people failed at almost every single thing that I mentioned here. Let's see. Yeah, I have it here. So, any of you use like CacheGrind or Valgrind? Oh, nice. So it's actually a pretty good profiling tool, which is going to give you a distribution of your load times. So this shows what's the resource usage for every single function. All right. CacheGrind or Valgrind, there's a couple of tools that will help you with that. Beauty of that is actually it's just a very small distribution, but as you can see, that it's got all the functions and the calls that you can actually figure out what's wrong with this. That said, without running the profiling, don't try to optimize for it, because I've had a similar conversation with a guy who kept on arguing that in examples I used, I put a semicolon on the same line versus a different line. And he argued that there is a difference in performance when you do this. And perhaps there is. I mean, I don't question different compilers. But if you're optimized at that level, perhaps you're using wrong programming language altogether, or you optimize it for the wrong thing. Because it's hard for me to imagine a use case where this would be a deciding factor. But anyway, so yeah, we used Valgrind to get it, and notice that, what's it called? Unreserved PHP was taking like 80% of resource usage on the page, right? I mean, we ran it across different pages, basically got an aggregate, and unreserved PHP was taking, what, 81%? Which is odd, right? It's one function, and it's not even a critical path, but it's everywhere, right? So we started digging deeper. And if you can see, it is code from the header.inc, which already started raising questions. And header.inc, as you can imagine, was code on every single page as part of the template. So I looked at the code, and this is the function that it was calling. And I'm going to walk through it. So it selects basically what the function does in a nutshell. It clears the stale shopping cart, right? So if you have a whole bunch of items in a shopping cart and you had it for a little extended period of time, it releases it. So, it releases inventory so people come in and don't see sold out when it's actually not. So it selects a whole bunch of IDs from the shopping cart, right? Where a time step is less than what they're trying to do. Okay. First of all, I don't understand why this function is called from the header, but let's wait on it for a second. So then what it does is, for each item it finds in the cart, it selects and sees how many orders were made with that cart, with that ID. So not for each item cart that you have, for each item cart anybody has in a system. And after that, that is not all. It updates items and set the reserved to nothing, so basically unreserves those. And after that, it deletes from items. I'll let you think about it for a second. It took me a few minutes to go back and forth a couple of times just to try to comprehend the logic. So what it does is, just to recap, what it does is it selects everything from everybody's shopping cart. It then selects for every single item we get back, it selects everybody from actual orders to see what they happen. Then it updates those items, and then it deletes those items individually. Remember the whole n plus 1? This is 3n plus 1. So if there's 100 items in a cart, you're running 301 queries. This is a popular e-commerce site. But that's not all. That's not all. After that, first of all, that was brilliant. That was just my favorite parts of this whole code. Like, the usefulness of this comment is just... But anyways, but that's not all, because after it does all of that, it sends a mail. The same cron job has run successfully. I don't know why you would think it's a cron job, consider it's running from a header file, but sure. But that's also not all, because after that, it writes to a log on disk. Mind you, that happens on every single page load. Right. So going back to your question, I would have honestly never looked in this function because, I mean, it's legacy code, there's a whole bunch of weird stuff. But profiling tools show that 80% of the usage of the pages come from one function, and then you're like, okay, now I know where the problem is. And honestly, it can vary. I mean, there is all sorts of stuff that you can do to figure out what the problem is. I've had situations last Black Friday, like a year ago, where all of a sudden the web server started running out of CPU. And it was easily determined there was a problem with CPU. It also was determined there was a problem with ORM because it was object construction. But I had no idea which page. Like, that is really, I mean, I know it's Apache processor eating, so I know there's something like either API or a page, but I had no idea which. So a colleague of mine actually wrote a like 20-line dtrace script that basically parsed out the HTTP traffic and gave me a breakdown by page. Right? So you see, it's like, some pages have taken factor of 10 more CPU or factor of 100 more CPU than others. So then you figure out which ones are the biggest offenders, and you go try to troubleshoot and profile those. So it is a very incremental process to find performance problems. Valgrind, I think. VAL-grind. Valgrind, or I think there is a Kcache grind that does similar things. I'm pretty sure it will come up if you Google for profiling tools for PHP. Yeah. And it integrates pretty well with PHP, considering it's PHP conference. You basically put it in Apache. It does create overhead. Speaking of performance, it does create some overhead because you need to store all the data and then crunch it. But you can put basically a probe in your HTTP processes, and it will dump the information, which you can then graph and kind of massage. It's a pretty interactive tool. Cool. Alrighty. Thanks. I'll be here for the next little bit if somebody comes up with a question.